mouse up there. And how much time do we have? We got another 45 minutes. We come over here. What are we doing? We're doing down. What? 22 minutes. What did I say? I didn't mean to say that. Don't believe any of my math. All right? That's why, hey, maybe I didn't tell you the story about coding, right? So I really, when I code, I say 45 instead of 21, and my code doesn't work. But the one time I said I never had working code as an undergrad, but it's a lie. There was one time we had to work in pairs, and I joined up with a student who really was struggling, but they were meticulous at typing. And I explained the algorithm to them, and they typed it in, and together it ran the first time, right? So you need a team. You need a team. All right, what are we doing? So really, you know, I say we're falling behind, but maybe we're not, right? We got hash tables, which will take us a class or two classes. And then in graphs, I got to talk to Jackie about what we cover, because I've been covering Dijkstra's algorithm, and I heard rumors from a student he doesn't. So let's find out what we cover there. And paradigms is definitely warming up for 3101. It's not what we're doing. All right. So we're going to do hash tables here, and maybe we're just laughing. We'll find out what graph algorithms Jackie wants us to teach. All right. And you know I'm more of a math guy, so I'm going to not scare you too much with the math, but I get excited about the math here. And Jackie might do less math. I don't know, right? So if there was a different, I would say that what was our last topic was heaps. Maybe Jackie would make you code up some heaps, and I would make you change the picture. Right? Yeah. Well, I just panicked there. I've never taught with Jackie before. Did you know he was my student in this course? Right? All right. So I don't know. My children are now 32. I don't know. Right? I could have taught all your parents, right? So I don't know when it was. I don't know how old Jackie is. But it's possible that on a topic like heaps, he's going to go for the coding, and I'm going to go for the changing pictures. So I didn't think of that when I talked to him, and I thought we'd have the same questions. But I should confirm with him which one are we going for. All right? But really, I mean, if you need to bubble this guy down, could you hack together some code to do it? Pseudocode, yeah. Let's research that. All right, I'll talk to Jackie about it. And in this topic, right, he might want code, and I definitely like the math. All right. And I've never, on my tests, I've never had hard math. But of course, you know, I say that, and all math is easy to me and hard to you, right? So, all right, so we're going to do hash tables. All right, so let's begin with a game in which we have holes and we have balls, right? And we're going to take the balls and we're going to throw them into the holes randomly. Each ball is going to go into a random hole, right? We flip coins to decide which ball to go in. And we have M is our number of holes, bins, right? And we're going to fill it up with half as many balls, right? And right, that's our game. And then you can ask very interesting questions. You can ask, how well to the ball, what do you expect, right? What are the worst case? Well, the worst case would be all the balls go into one hole. And is that possible? Yeah, it's possible, but it's not very likely, right? What do we expect to happen? We expect if you take a random bin, right, a typical bin, it's half of them are going to have 0 balls, right? The expected number of balls will be, in fact, expected number of balls will be a half, right? But you're not going to have too many balls that are really big, right? And you're going to have about one ball that is of size, one bin that's about size log n, right? Does that kind of make sense? Right? And I could write down the math to prove this, and it's more than you probably want. All right? But everybody can kind of get what we care about is most bins, all but a small number of bins will have constant size, and a constant number of bins are going to be log n size. And really, unless you really are unlucky, there's not going to be a bin containing all the balls, right? All right. So what is our problem is doing a dictionary, right? And you guys, oh, here's a little hint for the test on Monday. You're supposed to know about these heap things, right? Do you know about these heap things? The heap data structure, hash table, sorry, hash type, right? This is what we're doing. We're doing hashing here. Hash, and what is a hash table? It's just what we're talking about here. You have keys and you have values, right? The key could be the word, and this could be the definition. The key could be my social insurance number, and the value is everything stored with it, right? And what do you want to do? Right here, what I'm just saying, right? And what do you want to do? You want to be able to say, I want to insert this into the data structure, right? I have a new key, a new data, I insert it in, right? If it was there before, then you can let me know, right? Right? Maybe we allow it in there more than once. And then I also want to retrieve things. And how do I retrieve it? Is, somebody outside was telling me that the key is something kind of random that was given to me, right? But no, key is the word that you're getting for the definition from. The key is the social insurance number that we know, right? So you know, and you say, hey, key, I have a key, give me the value back, right? Everybody get this data structure? And I can say, hey, key, here's a key, remove it. Delete it from the dictionary, right? I need to be able to say how many things are in the queue. I have to know, is the queue, not a queue, what is it called? A heap data structure, right? I want to say, how big is it? Is it empty, right? So these iterators become harder, right? I might want to iterate through the keys. I might want to iterate through the values. And we're going to see that that's harder, all right? So I didn't type this page in, but here is an example where you're adding things and you're getting the information, you're removing things, right? And here's our data structure, things come in and out, right? People kind of get what we're doing, right? Here I say, get 7, and I go through and I find, oh, 7, the information's B, right? So I return the B, right? Everybody good? So what are the these are what we said before. One implementation is you store it in an unordered array, and the problem, you can insert fast, but it takes you a long time to search, right? And to delete. We can do it in an ordered array, right? So here they're ordered. And then the searching is fast. The inserting, well, you got to make room for it, so it's slow. Deleting somebody might be slow, right? Same with kind of linked lists, right? Same sort of problems happen, right? Because you got to find where it goes, right? You can do binary search trees, right? And then every operation takes log n. Everybody with me here? And we're going to do hash tables, which the claim is you can do everything in constant time, right? Which is a bit of a miracle, right? And bit of a lie, depends on what you count, right? Now, the problem with is these iterators. If you want to iterate them through in some order, then these might be good. But this guy here has nothing about order, right? Everybody kind of get that?